Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about productivity and efficiency. This topic is based on a tech blog with the title Innovation Demands Compute: How Meta is Enabling ML Productivity and Efficiency at Scale, written by their data science team. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. To understand Meta's approach to AI productivity, we first need to look at the company itself. Formerly known as Facebook, Meta has transformed from a social media powerhouse into a leader in artificial intelligence and machine learning research. A key part of its vision is to develop artificial general intelligence in an open and responsible way. This is to ensure its benefits reach as many people as possible. Achieving this ambitious goal requires massive investment in computing power and efficiency. AI is not just a tool at Meta, it's a fundamental part of the operations. Whether it's about ranking content on Facebook and Instagram, improving augmented reality experiences in the reality labs, or to ensure accessibility with auto-generated text, AI is at the heart of all of this. One of Meta's biggest breakthroughs has been in generative AI. Let's take Llama 3.1 for example. It was released in July 2024 and it was the largest open source language model at the time, boasting 405 billion parameters. Training such a model required optimizing the entire machine learning pipeline and utilizing over 16,000 H100 GPUs, which is a staggering engineering feat. The need for such immense computing power is driven by scaling laws, which is a fundamental AI principle stating that performance improves as models grow larger, databases expand, and computational power increases. Meta knows that staying competitive in AI requires continuously scaling up the models. But scaling AI to its level comes with a major challenge: compute capacity. Large models demand enormous resources, and the global shortage of GPUs has created bottlenecks across the AI industry. Even for a company like Meta, efficiently managing its computational infrastructure is critical to sustaining the innovation. Now that we've explored the business problem, let's shift gear and dive into the technical side to examine the possible solutions. GPUs are a limited and costly resource, which makes it crucial to maximize return on investment, which is ROI in short. To address this, Meta's analytics team has developed frameworks to define and measure success in two key areas: productivity and efficiency. Productivity measures the relationship between outcomes, such as engineered features, trained models, and deployed models, and those inputs, like computing capacity and developer headcount. This productivity serves as a leading indicator of future returns. In the short term, it ensures that developers have the tools and resources needed to maintain a steady development pace. And in the long run, increasing outputs across the machine learning development pipeline can accelerate the creation of high-quality AI models. The second concept, efficiency, focuses on how effectively inputs are utilized. It is often measured by GPU utilization rates or the percentage of resources allocated to high ROI tasks. Efficiency improvements ensure that computing power is used optimally rather than wasted on low-impact tasks, such as the overhead or models with minimal production traffic. In a capacity-constrained environment, productivity and efficiency are closely linked. Reducing idle or low ROI capacity frees up the resource for high-value tasks, and more efficient resource allocation allows teams to build and deploy AI models without increasing costs. As efficiency improves, productivity naturally increases and enable the team to achieve more with the same resources. One concrete example that Meta enhances efficiency is by optimizing idle capacity. Some idle resources, such as disaster recovery and push buffers, are necessary. However, other idle capacity results from inefficiencies, such as mismatches between hardware availability and demand. Meta's analytics team leverages real-time GPU metrics to detect underutilized resources, and by collaborating with engineering teams, they optimize hardware usage to ensure that available compute power is not wasted. One approach involves improving hardware fungibility, which allows the training jobs to use idle inference capacities, thereby maximizing the resource utilization. Now, we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored Meta's AI scaling challenges and how the company leverages productivity and efficiency to optimize its compute power. We also discussed how analytical insights can help identify active levers to improve AI development. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.